AI matches the abilities of the best math Olympians. Until now, computers have failed to solve mathematical problems. But the AI program AlphaGeometry has succeeded in finding proofs for dozens of theorems from the International Mathematical Olympiad. The International Mathematical Olympiad (IMO) is probably the most prestigious competition for pre-university students. Every year, students from all over the world compete for its coveted bronze, silver, and gold medals. 112 countries took part in 2023. In a new twist, AI programs could soon be competing with them too. A team led by Trin of Google DeepMind and New York University unveiled a new AI program called AlphaGeometry in the journal Nature on January 17th. The researchers reported that the program was able to successfully solve 25 out of 30 geometry problems from past IMOs. This gave it a similar success rate to the best human participants who have won a gold medal in the competition. The AI also found a more general solution to a problem from the IMO in 2004 that had previously escaped the attention of experts. Mathematical Olympiads are the most reputed theorem-proving competitions in the world, wrote Trin and his colleagues in their recent publication. Over 2 days, each competing student has to solve a total of 6 problems from different mathematical domains. Some of the problems are so complicated that even experts cannot solve them. They usually have short, elegant solutions but require a lot of creativity. This makes them particularly interesting from the point of view of AI research, which is aimed at developing systems with creative abilities. Until now, even large language models LLMs such as OpenAI's GPT-4 have failed at such tasks. One of the reasons why AI programs have so far not met with success is their lack of access to data. LLMs such as GPT-4 are trained with tens of gigabytes of text files, which correspond to around 20 million letter-sized pages filled with words. Translating a proof into a programming language that computers can understand the language lean is one example that requires a great deal of work. This is particularly difficult in the field of geometry, where proofs are usually even harder to formalize so that a solution can be computed. Although there are formal programming languages specifically developed for geometry, they make little use of methods from other areas of mathematics. So if a proof requires an intermediate step in which, for example, there are complex numbers that may contain square roots of negative values, programming languages specialized for geometry cannot be used. This is why Trin and his colleagues created a dataset that doesn't require the translation of human-generated proofs into a formal language. To do this, they first had an algorithm generate a set of geometric premises, or starting points, for example, a triangle with its heights drawn in an additional points marked along its sides. The researchers then used a deductive algorithm to infer further properties of the triangle, such as which angles matched and which lines were perpendicular to each other. Such programs have been available for several decades. They use predefined geometric and algebraic rules to make statements about geometric objects. By combining the premises with the derived properties, the researchers were able to create a suitable training dataset for their AI that consisted of theorems and corresponding proofs. Google for more information at Scientific American on AI matches the abilities of the best math Olympians.